Matematika. Today we're going to do 1.11b equivalent representation of polynomial and rational expressions. If you are given a polynomial function f of x equals 2 times x plus 2 squared, the usual thing we do is we multiply the x plus 2 times and do the distributive property. So this will become like x squared plus 2x plus 2x plus 4. And multiplying and distributing, this will be x squared plus 4x plus 4. So your standard form will be 2x squared. 2 times 4, that's 8x plus 8. And that's how polynomial function should be written in standard form. How about in rational form? You are given the f of x equals x plus 1 times x minus 5 over 3 times the quantity of x plus 3, x to the third plus 1. So if you try to do an inspection, you cannot find a common factor. So that means we have to expand and multiply the numerator. That would be x squared plus x minus 5x minus 5. And the denominator would be 3x cubed plus 3. So simplifying, that would be x squared minus 4x minus 5 over 3x cubed plus 3. All right. Rational functions can also be rewritten in various forms to expose different characteristics, and this includes the asymptotes, the vertical, the horizontal, and the slant asymptotes. We have shown that in the previous video. While polynomial long division can be used to rewrite a rational function, like this given, and you are asked to find the slant asymptotes of 3x cubed minus x squared plus 2x minus 5, we divided by x squared minus 5. So by doing this, we can identify the slant asymptotes. How? Because rational functions are quotients of these two polynomials here. And it's the same way that we're going to rewrite by dividing by using the long division. So if by doing this, we say 3x cubed minus x squared plus 2x minus 5. We divide it by x squared minus 1. Alright? Okay, first term to first term. So what is our first term here? 3x cubed divided by x squared. This divided by x squared. So we have 3x. Okay? So multiply back, this will be 3x times x squared. That will be 3x cubed. 3x times negative 1, that's negative 3x. Okay, there's a space under x squared because we have no x squared there. Okay? When we subtract, change the sign. This will be minus and this will be plus. So we can cancel out, bring down negative x squared. 2x plus 3x, that's 5x. and then bring down negative 5. Okay? So we divide again negative x squared by x squared. So we have a negative 1. Right? Multiply back. That will be negative x squared. Negative 1 times negative 1, that's positive 1. Alright? So change the sign. By subtracting, this will become positive. This will become negative. So cancel. This will become 5x minus 6. This is the remainder. But we need, for slant asymptote, we need only the quotient without the remainder. So in other words, the slant asymptote here, okay, would be y equals 3x minus 1. Okay. By rewriting a rational function in different forms, we can identify various characteristics. As I've said, all asymptotes, horizontal, vertical, and slant asymptotes, we can find the intercepts for polynomials and all those stuffs that we have done already in the various, in the previous video we have. Now let's go to Pascal's triangle. In geometry, we started learning about Pascal's triangle in geometry. We found combinations by using this formula. N choose R is equals to n factorial over n minus r factorial times r factorial. This uses factorials, all right, where n is the total number of objects and r is the number of objects being chosen. So, what is a factorial? A factorial is a product of the first n positive integers. Like n factorial, that would be n times n minus 1 times n minus 2, and so on until 2 times 1. Alright, for example, you have 4 factorial. So that would be 4 times 3 times 2 times 1. And then you multiply it. 4 factorial is equals to 24. Now, let's try to look at this and try to explore. You have, using the factorial formula, you have 4 choose 0. So our n here, the n is 4, the r is 0. That means we have 4. I'm going to write it this way. So I'm going to have n factorial, which is 4 factorial, over n minus r. This is 0. N minus r, 4 minus 0 is 4. So it's still 4 factorial times r factorial. So our r is 0. So 0 factorial. So that this would be 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. If you look at this, you can cancel that out. That means if you have the same numerator and denominator factorial, you can easily cancel that out. Just cancel it out. Well, 0 factorial would be, so canceling, 0 factorial is 0. But canceling 4 factorial and 4, that's equals to 1. Okay? So 4 choose 0 is equals to 1. How about 4 choose 1? 4 factorial, that will be 4 minus 1, that is 3 factorial, and 1 factorial. So 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1, while 1 factorial is 1. Okay? So that means we cancel this. Our 4 choose 1 is equals to 4. Okay. 4 choose 2. Let's explore. 4 factorial over 4 minus 2, that is 2 factorial times 2 factorial. So 4 times 3 times 2 times 1. 2 times 1 for 2 factorial, and 2 times 1 for the other 2 factorial. We can cancel this out. So 4 times 3, that's 12. And then you divide by 2, that is 6. So 4 choose 2 is equals to 6. I have to make this closer. This is equals to 4. This is equals to 6. How about this? 4 choose 3. So this will be 4 factorial. 4 minus 3, that's 1 factorial, and 3 factorial. So you have 4, 3, 2, 1, and that is 1. Then you have 3, 2, 1. So cancel, you have equals to 4. How about 4 choose 4? So 4 factorial over 4 minus 4, that's 0 factorial, over 4 factorial. 0 factorial is nothing, it's 0. Cancel out, that would be equals to 1. Now, let's look at the Pascal's triangle. I hope you can remember the Pascal's triangle in geometry. So the triangle we're gonna explore today was discovered by a French mathematician. His name is Blaise Pascal on the 17th century. Although we call it the Pascal's triangle, students from other areas of the world knows it by a different name. So in India, they call it the staircase to Mount Meru, attributed to the Indian mathematician Halayuda from the 10th century. In Iran, they called it Khayyam's triangle. In China, they called it the Hangyu's triangle. But usually, most of us are calling it as the Pascal's triangle, named after Blaise Pascal. So how does the Pascal triangle? In those days, there was often no means of sharing something or published in other countries that the mathematician of the other world discovered the concepts. So there are other names in other countries, but we call it, as I've said, the Pascal's triangle. So how would we do the Pascal's triangle? Actually, if I write it this way, to begin with, we start with 1. Okay? The next row, we begin with 1 and end with 1. So it will be 1 here and 1 here. Begin with 1 and end with 1. For the next row, that's the third row, we begin and end with 1, but we find the middle number by adding the two numbers above. So I begin with 1, but I add this two number 1 plus 1, that is 2, and I end with 1. Okay? Then do the steps as we move on. Then we begin with 1 and end with 1. Find the middle number by adding the numbers to it. So I will have begin with 1. So 1 plus 2, that's 3. 2 plus 1, that is 3. And then I have 1. And that is how we do. Doing the next step again. 1 plus 3, that is 4. 3 plus 3, that is 6. 3 plus 1, that is 4. And end with 1. And that is how you're going to write it. So begin with 1. 1 plus 4 is 5. 4 plus 6, that's 10. 6 plus 4, that's 10. 4 plus 5, 4 plus 1, that's 5. And end with 1. Do the same thing. Start with 1. 1 plus 5, 6. 5 plus 10, 15. Then this is 20. This is 15. This is 6. And end with 1. And so on. So what do we have, or what do we observe? We have a pattern. Okay? We have a pattern. And then this pattern has a symmetry. Okay? 1, 3, 3, 1. 1, 4, 6, 4, 1. So the middle there is 6. 1, 5, 10, 10, 5, 1. So the middle is between 10 and 10. That would still be 10. And so on. All right. Let's discover more. All right. Now using the Pascal's triangle, by doing what we did using the factorial, how it corresponds to 4 choose 0. 4 is the fourth row. This is the first one is the 0 row. So this is the first, this is the second, this is the third, and this is the fourth row. Okay? So in the fourth row, this, we have 1, 4, 6, 4, 1. So that means 4 choose 0. This is 0. When you count the term, it will be 0, 1, 2, 3, 4. So there are actually 4 terms, but you can see 5 of them. But start counting from 0. So 4 choose 0 is 1. So do we get 1 there? Yes. 4 choose 1, it's 4. 4 choose 2, that's the second term, it's 6. 4 choose 3, it's 4. 4 choose 4, it's 1. And by using the Pascal's triangle, you can get the answer right away without using the factorial or the Pascal's triangle formula. But just use the Pascal's triangle. Okay, let's do more. So in other words, by doing that, if we are given, I have here a 1-to-1 correspondence. The first one here correspond to 0 choose 0. This one, 1 choose 0, 1 choose 1, 2 choose 0, 2 choose 1, 2 choose 2. And so on. 3 choose 0, 3 choose 1, 3 choose 2, and so on. So that is how it corresponds when you are given that symbol. So the notation of, when you have this in the factorial notation, n choose r may be also used in the combination. Find row 10 of Pascal's triangle. So let's say I'm doing the thing that I did from here. Keep on going until you can get the row 10. Okay? So supposing the row 10 is here. Okay? Find the row 10 of Pascal's triangle. So this is the row 10 right here. So what would be the answer? 1, 10, 45, 120, 210, 252, back to 210, 120. Oh, I'm going to write it here. I want it in a straight. Oh, I just have it here. It's here. This is the row 10. 110, 45, 120, 210, 252, 210, 120. Look at this. They are symmetrical. That's the pattern, right? This is very important because when we do some problems later on, you looking for the middle term, it's easy for us using the Pascal's triangle. Okay, let's do the next question. Evaluate 6, choose 3 using the Pascal's triangle. So our n here is 6. Our r is 3. R is the term, 6 is the row. So if I look at here, I have this 1, 6, 15, 20, 15, 6, 1 as the terms of row 6. Okay? So, the fourth entry, because you count this as 0, entry, 1 entry, 2 entry, 3 third entry. I mean, this is the 1 entry. This is the 0 term, first term, second term. But the entry is 1, 2, 3, 4 when you count that. Okay? So that means the fourth entry is 20. 6 choose 3 is equals to 20. Without any computing, we want to prove it. Okay? So let's do 6 factorial. That would be 6 minus 3, n minus r, is 3 factorial. And then r factorial. That means 3 factorial. I have to be clear. Where did you get the other 6? So the other 3 is 6 minus 3 factorial and 3 factorial. So that would be 6 factorial is 6, 5, 4 times 3 times 2 times 1. While 6 minus 3 factorial is 3 times 2 times 1. And the other one is 3 times 2 times 1. I can cancel this 3 times 2 times 1 right there. Right? So 6 times, how much is 6 times? I could have this. I could reduce this 3 by 6, that's 2. 2 by 4 by 2, that's 2. So 2 times 5 times 2, that's equals to 20. Okay. So same thing. It's much easier if you are looking at the Pascal's triangle. Okay. You are asked to evaluate 7 choose 4 using the combination formula. So what is the combination formula? N choose R. That would be n factorial, n minus r factorial times r factorial. So we have 7 choose 4. That means 7 factorial, 7 minus 4, and then 4 factorial. So 7, 6, 5, 4, 3, 2, 1 over 7 minus 4, that's 3 factorial. So I could have 3, 2, 1, and then 4 factorial is 4, 3, 2, 1. I could cancel this. I could see what I can cancel right away. So I could cancel 3 and 6 by having that as 2. Alright, so I could cancel 2 and 2. So what is left is 7 and 5. That's equals to 35. Let me grab some water, please. Okay. Well, using the Pascal's triangle, let's do this using the Pascal's triangle. 7 choose 4. So 7th row. Then 4. 1, 2, 3, 4. I have it as 35. Okay? 7 choose 4 as 35. So we can find the value using the combination formula for finding the value of n choose r using the combination formula. Okay. Let's move on to binomial theorem. Okay. In binomial theorem, when we say binomial, two terms inside, a plus b. This is a binomial because there are two terms. Okay, I'm gonna write this space here. Alright. A plus b. So, say for example, you're asked to evaluate that a plus b to the 0 power. Anything that has a 0 degree that's equals to 1. So we don't have like anything to compute with. That's the rules of exponents. So we have a plus b to the first power will be a plus b. If you have a plus b right here to the second power, you're gonna write it as a plus b and a plus b. Disregarding your knowledge in the square of a binomial, because if you know, then you can do the square of a binomial right away by doing the a squared plus 2 times a times b plus the square of the last term. Same thing if you have a plus b to the third power, you can use also cube of a binomial. By doing that, you can say a minus b as the first factor, and you can have a squared minus 2ab plus b squared. And then you can multiply and expand. But how about if you are having a more higher degree? It will take us maybe time, so much time to do an expand. Okay? So by doing this, we can use the binomial theorem formula. Okay? So this is known as the binomial theorem. You have a plus b raised to the nth power. That is the summation. This symbol is a capital sigma symbol, summation, or the sum of from r equals 0 to n, and n choose r, times a to the power of n minus r, times b to the power of r, where n is the exponent of the binomial, a is the first term, b is the second term, r is an integer value from 0 to n. Okay? So, how are we going to do that? Using the binomial theorem. You have n choose 0, start from n to choose 0, then a to the power of n, b to the power of 0, plus n to the n choose 1 again, a n minus 1, b minus 1, and so on, until you reach to n choose n, a to the 0, b to the n. And how it should be written, and how does it goes. So for example, you have a plus b to the fourth, because that is where I stop here, right? That's a very long solution. All right, let's do this. I'm going to start with n, choose 0. But the end is 4. So this will be 4, choose 0. So that would be a, to remember that we have to subtract n minus r. So n is 4 minus 0, then b to the 0, because that is b to the r. Alright? Then I have 4 choose 1. That would be a 4 minus 1. That is 3. Then b to the first. Again, 4 choose 2. This will be 4 minus 2, that's 2. Then the b would be 2. That's the r. Whatever r that is the exponent of b. Then I have 4 choose 3. A now would be 3. 4 minus 1, minus 3. That is 1. Then the b would be 3. Then I reach now 4 choose 4. A will be 0 and b would be 4. Now, if you try to observe, okay, I will simplify this. If you try to observe, the a is looking at the exponents on the variables in the expansion. The exponent of the first term, 4, 3, 2, 1, 0, is descending from beginning until n, ending at 0. While the exponent of the second term is 0, 1, 2, 3, 4. It is ascending. So one is descending, the other one is descending, beginning from 0 at ending at n. This is, a is beginning from n to 0, while the b is from 0 to n. So simplifying, okay, let's simplify. If we look at the term, I'm looking at my Pascal's triangle now. B to the fourth, I will expand this. So this is b to the 0. B to the fourth will be here. There. So I know that this will stand for the coefficients. So I have 1, 4, 6, 4, 1. So 4 choose 0. This is 0. It's 1. Times a, 4 minus 0, that's a to the 4th. B to the 0 is 1. So 4 choose 1. That is equals to 4. That's my coefficient. A to the 3rd, B to the 1st power. 4 choose 2. It's 6. A squared, B squared. 4 choose 3. It's 4. Or again, A to the 1st, B to the 3rd. And 4 choose 4. It's 1. A to the 0, it's 1. 1 times 1, it's 1. B to the 4th. So to finalize the answer, this will be a to the 4th, 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. And that is the expanded form of a plus b to the 4th power. Okay. Let's do this. All right. Use the binomial theorem to expand the following expression. First of all, you have to identify your first term. Let's do it in the fast way, not in the long way, using the factorial combination formula and using the binomial theorem. Okay? We can use the binomial theorem, but I want to do it in the fastest way, using the Pascal's triangle. All right. So the first term is 5x. The second term is first, second is negative 7y. And the n is 3. That means n is 2. Okay, I'm gonna look for n when it's 2. So this is 0, 1, 2. I have a 1, 2, 1. Okay, my coefficient should be 1, 2, 1. Or I could do the choose 0. And then first term, I have to do this first. Second term, before I assign the exponent. And then move up to choose 1. I will write the first term and second term. Then until I have 2, choose 2. First term, second term. Okay, I want to do it in the fast way. So I have 1, 2, 1. So 2, 0 term, that's 1. But my 5x should have a 2 minus 0. Start from 2. So this will be 2, 1, 0. Well, this is 0, 1, 2. Because the first term is descending from n to 0, while the second term is ascending from 0 to n. So 0 to 2. And that should be the case. So negative 7y to the 0 is 1. 2 to 2 choose 1 is 2 times 5x times negative 7y. Then 2 choose 2, it's 1. 5x to the 0, it's 1. And negative 7y squared. Let's simplify. 1 times 1, 5 squared is 25. X squared. Alright. Then 2 times 5, that's 10. Times negative 7, that's negative 70 xy. 1 times negative 7 squared, that's 49 y squared. This is your expanded form of 5x minus 7y without using the summation or anything. But actually, we are doing the summation here using the Binomial Theorem. But we are doing it in the fastest way, using the Pascal's triangle. Find the middle term. Okay. Find the middle term of the expansion. We still have one. P plus 4 to the fifth power. Okay, 5. So our n is 5. Our first term is P. Second term is 4. So I'm going to write it here. Since it starts with 5, choose 0. P times 4 plus 5, choose 1. P times 4 plus 5, choose 2. P times 4. 5, choose 3. P times 4 plus 5, choose 4. P times 4. I have it plus 5, choose 5. P times 4. Alright. I will assign the exponents now. Since it starts with 5, what did it say? N minus R. Okay, our R is 0 here. So, P to the 4th, P to the 3rd, P to the 2nd, 4, 3, oops. 5 minus 0 is 5. Sorry, I made a mistake. So it starts with, the P starts with 5, 4, 3, 2, 1, 0. So the N start with 0, 1, 2, 3, 4, 5. So we have the assigned exponents now. Now we will look for, I'm going to look for fifth row to the Pascal's triangle, B to the fifth. Okay, make it big here, right here. 1, 5, 10, 10, 5, 1. That's B to the fifth. 1, 5, 10, 10, 5, 1. Okay, I'm going to write it here. 1, 5, 10, 10, 5, 1. It's symmetrical. We have 6 terms. Alright, I'm making it this small. 5 to the 0 Start here. That's 1. P to the fifth power. 4 to the 0, it's 1. 5 to the first, it's 5. Then P to the fourth times 4. Plus 5 to the second. That 5 to the 5 choose 2. 5 choose 1. Sorry for that. 5 choose 0. So 5 choose 2 is 10. P to the third 4 squared. That's I will have it directly. 4 squared is 16. 5 to the third 0 1 2 5 choose 3 is 10. Then P to the second 4 to the third 4 times 4 16 times 4 64. I have it here. 5 to the fourth, that's 5. P to the first. 4 to the fourth. 256. I have to be sure. Let me get my calculator right here. 5 to the fourth, it's 625. 4 to the fourth. 4 to the fourth, it's 256. I'm right. Then 5 to the 5 choose 5 is 1. P to the 0, it's 1. 4 to the power of 5. 4 to the power of 5 is 1024. Okay, let's finalize the answer. So the first term here is P to the fifth. 5 times 4, that's 20. P to the fourth. Then 16 times 10, it's 160. P to the third. 10 times 64, 640. P to the second. 5 times 2, 5, 6. That's 1,280. P plus 1024. All right. So this is the P plus 4 to the power of 5. Okay, the last one. Find the middle term in the expansion of 2x cubed minus 3y squared to the power of 8. Okay. So, let's have this. So, our A, first term, would be 2x cubed. I have to be specific here. The B is negative 3y squared. The N is 8. So, middle term, the nth term, if there are 8, the R should be 4. 1, 2, 3. Okay, let's do this. Let's use the formula of A plus B expansion formula. So N choose R times A, N minus R, B to the power of R. Let's substitute. N is 8. So A choose 4 times 2. The first term, A is 2x cubed. That would be 8 minus 4. And then the B is negative 3y squared r, where r is 4. Okay, so this would become, let's use a factorial here. 8 factorial. For c, choose 4. So how do we write c, choose 4? 8 factorial over 8 minus 4 factorial times 4 factorial. Okay? Then we have 2x to the third. 8 minus 4 is 4. And negative 3y squared to the fourth. Okay, let's do this. The factorial is, I'm gonna do the factorial here. I could do 8 factorial as 8, 7, 6, 5, 4, 3, 2, 1. And the 4 factorial is 4, 3, 2, 1. And the other one is 4, 3, 2, 1. 4, 3, 2, 1 can be cancelled out. 4 and 2 can be cancelled out with 8. So I have what is left in the denominator. I have 3, 3, and 6. I could cancel that out. So I have 7 times 2, 14 times 5. That is 70. Then 2x to the third, 2 to the fourth, 2 times 2 times 2, that's 16. X to the power of 12. Negative 3 to the fourth is 3 times 3, 81. Y to the power of 8. So we have 70 times 16 times 81. Let me get my calculator here. 70 times 16 times 81. 90720 x to the power of 12, y to the power of 8. I have it here. And can we find it in the let me go to the where is my to the 10th. Okay, we have to we found it here, the 70, the factorial. Okay, without using the factorial, you can find 8, choose 4 in the Pascal's triangle. Okay, you can find that. So in other words, you have 8 choose 4 in the Pascal's triangle is equals to 70. And then you multiply it with the first term and the second term. Alright, let's summarize. So using binomial theorem, you have a plus b to the power of n. That summation of from r to the 0 to n choose r times a to the power of n minus r b to the r, where n is exponent, b is the first term, b is the second term, and r is an integer value from 0 to n. So each individual term would, in the form of n choose r, is a to the power of n minus r, b to the r. And we can use this expression to find the r plus 1 in the term of expansion. So we're going to have more on this in the problems and solutions on my next video. So let me say this. If I can do it, so can you. Please don't forget to hit the like button and the subscribe button as well. See you in my next video.